This is a short demo of how hash-partitioned data acquisition works in practice. What I will do is quickly go over the setup, which is exactly what I described in more detail in the blog post. That is Azure SQL Database, a link server on my local instance of SQL Server, and finally, the two stored procedures I'll be using to showcase this solution. To start with, we have a table which we can access through the link server connection. This is our dummy data, which I generated using a small script. The important part is that it has 300 columns across 100,000 rows and is populated with synthetic text data of different length. If I go ahead and select a subset of data, you can see that it's just dummy entries, which make no sense, but for the purpose of this exercise, it's mimicking how white tables can be structured. You can also see that the target table, the one we will be loading into, is empty. Finally, we have two store procedures, one which acts as a coordinator and another one which does all the heavy lifting and is responsible for the data insertion. The first store procedure, or the parent store procedure, is used as a coordinator. Its main purpose is collecting and processing required metadata, dispatching queries, building SQL Server agent jobs, and also tracking the number of concurrent executions. The second one is taking all the metadata passed through from the parent and performing the actual data loads. So those two work in unison in a parent-child or master-worker type of scenario. I will not go over the technical details of the code. You can investigate it yourself, as I've left the download link to my OneDrive folder where all the solution files are located in the blog post. What I will do, however, is quickly demonstrate what those two store procs do and how you can speed up the acquisition process using this technique. So, as stated before, we have our source table with some data, and we would like to break it into chunks or partitions and move this across into the target table using multiple concurrent loads. If I trigger this process now in a debug mode, you will see that we have some useful metadata information returned. And if I switch over to the messages view, you can see we have a number of partitions with the starting and ending hash keys printed out as output. The number of concurrently executing jobs specified for this demo is 8. As this runs every 5 seconds, it will go off and check the heartbeat and print out the number of active loads running. This is currently capped at 200, which is the value of one of the adjustable parameters in the code, just to make sure that in an unlikely event any of the loads get stuck. Once we get to that 200 number, they are terminated gracefully and removed out of the pool of executing jobs. We can also check what's happening on the instance using Atom Mechanics SP who's active, and you can see current active queries. This will take a few moments to process, so I'll pause the video for a short time and return when finished. Okay, we're back, and as you can see, the process is finished, and all things well, we should be able to see exactly the same data across our source and target objects. Let's fire off a couple of quick validation queries, and we can see that the counts are matching, which is a good thing. Also, I will pull in the source and target data, just the first 5 records, into a temp table. That's due to the fact that the collation used on my local instance is different to that on Azure. And looking at those values, we can see that they are identical, which seems to suggest that with the counts matching, the whole data set was acquired successfully. That's it. Hope you found it useful, and thanks for taking the time to see this demo.